Hi guys, there was a question from last week. I recalled it was 5p minus 1 x squared minus 4 x plus 2p minus 1. And we were asked to find the values of p which will make this quadratic a perfect square. So we're looking for a perfect square. Perfect square. It means that we have a solution as an example of, like, say, x minus 1 all squared. That's a perfect square. So that means there's only one solution to this equation, which is x equal a. Right? Just this is just a side note. Now, perfect square means one solution. So that implies a bracket there, one solution. This should then ring the bell of the discriminant from year 10, which we labeled as a triangle. And the discriminant is equal to, if I remember correctly, it was b squared minus 4ac. And then once we obviously, for a is equal to 5p minus 1, b in this case is equal to negative 4, and c is equal to the constant, which is 2p minus 1. So it was said that if the determinant is equal to 0, that means we have one solution. If the discriminant is bigger than 0, then we have two solutions. If the discriminant is less than 0, we have no solutions, or 0 solutions. Or no real solutions. 2 real solutions and 1 real solution. Now, we're obviously going to be interested in this bit here. Reason being is because we're looking for a perfect square, and perfect square will have one solution. See, perfect square will have one solution. In order for us to have one solution, the discriminant must equal to 0. So that discriminant, this value here, must equal to 0. Therefore, I'm going to substitute discriminant being 0 equals b squared, which was negative 4. I'm going to square it. And then minus 4 times a. In this case, a was 5p minus 1. And then multiply that by c, open bracket again, and go to 2p. I'm going to tidy it up. So when you multiply these out, you get that there bit in the bracket. So now I'm going to do the same to the 4. So we have 0 equals 16 minus 40 p squared plus 28p minus 4. Now I have two constants. Can reduce them, so I go 0 equals 12 minus 40 p squared plus 28p. Then I can divide everything here by 4, 4, and 4. Yep, I can divide everything by 4, so divide by 4. If I divide by 4, I get 0 divided by 4 is 0, and that equals to 12 divided by 4 is 3, minus 10 p squared plus 7p. Now I'm going to rearrange this just a little bit, just to make it familiar to myself. 7p plus 3. Now this is just a normal quadratic. To solve this quadratic, there's a couple of ways. You can use the general form, or I'm simply going to use the splitting the middle term. Term. So splitting the middle term, it means that we're going to look at the first and the last term and multiply them together. So just the numbers, we get negative 30. What are the two numbers that we add? We get 7. That are also products. When you multiply them together, you get negative 30. So the numbers are 10 and 3, because plus 10 and negative 3, if you add them together, you get 7, and if you multiply them, you get negative 30. So it means that I can split this term here into these two, and I'll show you how. So then that 7 could be written as plus 10p minus 3p plus 3. So you see here that the 10 and the 3p, when you add them together, you get the 7. The 3 is the 3. The negative 10p squared is negative 10p squared. Pretty much there. Now, if I take negative 10p as a common factor, I end up with p minus 1. Common factor from here for this side. And if I take negative 3 as a common factor, I end up with p minus 1. Because if you go ahead and multiply this out, you'll get this one here. Right? Do it if you need to confirm if it doesn't make sense. So what you do then, in this case, I will take p minus 1 as a common factor between these two, because we've got one term here, another term there. I end up with negative 10p minus 3. So now, solutions for p will equal to 1, or p will equal to 3, or negative 3 on 10. So you let this part equal 0, you get p equal 1, and if you let this one equal to 0, then you take 3 to the other side, it becomes positive, you divide both sides by 10, it becomes negative 3 on 10. So these are the two values of p that will make this quadratic a perfect square. And that's it.